Hello, class. Let's go ahead and take a look at question numbers 12 through 14. We're on page 9 of the Unit 1B notes. So I want to take a look at question number 12 first. If AB is translated to form A prime B prime along the path of the dotted lines, which segments from the figure would be the same length and which would be parallel? So our original object is going to be AB, which I just highlighted in pink there. And we're going to translate that object. We're going to translate it or slide it over to be the blue segment. And the dotted lines in between those two segments are just there to show us the path that the lines took, or more specifically, the path that the points A and B took along the way. So now that we have a little bit of a better understanding about what the question is asking us, they want to know, with that translation, going from the pink to the blue, sliding that AB over, which segments from this figure are going to be the same length and which are going to be parallel. Well, a translation is going to move the object so that each point is moving the same distance and direction. And those two words are important: same distance, same direction. So my point B here is going to move the same distance to get to B prime as A is going to move to get to A prime. So let's say that we move B to B prime 5 inches, then A to A prime would also have to be moved 5 inches. That means that A prime, that segment that's dotted right here, is going to be equal to the segment B to B prime. And now when I'm creating an equation, I actually don't want the little bars over top. It's a naming convention that mathematicians use when we have an equal sign. So A to A prime is equal to B to B prime. We know that that is true. I also know that my original AB, if it was, let's say if AB, the original AB was 7 inches long, that A prime B prime would also have to be 7 inches long. So AB is going to be just as long as A prime B prime. Therefore, those two will also have to be the same length. Now I know that 7 inches and 7 inches are going to be the same because translation is an isometry, same shape, same size. Specifically, again, the same size. I have to keep that 7-inch distance between AB when I slide it. The fact that I'm moving these segments in the same direction is also going to give us a couple of sets of parallel lines as well. And those parallel lines are going to be in the same set as the sides that were the same length as well. So A to A prime, that segment is now going to be also parallel to B to B prime. And AB is going to be parallel to A prime, B prime. Again, that's because we are following the same direction when the objects are moved, so we're going to create some parallel lines there. Now, they didn't ask us for an explanation, but I will again stress that we know that the opposite sides are equal because we have the isometry. So I know AB is congruent to A prime, B prime because of the isometry. I know that A to A prime and B to B prime are both going to be, in this case, I put 5 inches, and that's because that same distance was used to translate. And I know that I have parallel sides because the same direction was used to translate. So we're using quite a lot of the properties of translation just to find which sides are parallel and which sides are congruent. Now I'm going to go ahead and kind of clean up my image here a little bit because I also see that we are going to be using the same image or the same diagram for question number 13. And they want us to label that AB is going to be 2x plus 1, and A prime B prime is 7x minus 9. Now in the previous problem I had said if AB was 7 inches, A prime B prime would also have to be 7 inches. We know that those two have to be the same because our original has to be the same size and shape as our new image if we are looking at a translation. So I can go ahead and set 2x plus 1 equal to 7x minus 9. And then I want to go ahead and solve my equation. I want to get all of my x's on one side and all of my numbers on the other. I'm going to start by moving my 2x over. You could move your 7x, but then you'd end up with a negative x. And I try to keep my x's positive if I can. Okay, so subtracting 2x from both sides, we get rid of the 2x's on the left, and 7x minus 2x gives us 5x. Now I want to move all of my numbers to the left side. I'm going to do that by using the opposite of negative 9, which is a positive 9 or a plus 9. We get rid of the 9's on the right side. And that gives me 5x equals 10. I'm going to rewrite that up here because I'm losing room. And now to get rid of the 5 in front of the x, I want to divide by 5. And that is going to give me a 2. So I have x equals 2. Now my whole goal was to find x when I'm solving this equation. And that's exactly what I did. I tried to get x by itself. So every step along the way, I was trying to get the x's moved to the right so that all of the x's were on the same side, move all of the numbers away from my x's, and then divide by the number that was in front of the x, all in an effort to get my x by itself. Now, looking at question number 14, I want to look at the following reflection. Okay, so I have a couple of triangles here, I'm going to go ahead and highlight like these. So I have a triangle right here and another triangle right here. So those are the two triangles that were reflected. This orange line here is going to be my line of reflection, and all of the other dashes are just measuring how far we are away from that line of reflection. Okay, so hopefully that picture makes a little bit more sense. I'm just going to re-highlight this left side triangle because I had covered up my variable and I couldn't see it there. So I'm going to go ahead and take a look at my values here. In a reflection, the definition of a reflection says that each point is going to be the same distance from the line of reflection. So I have these 2 points here. I'm going to call them real quick. I'm going to call that one A, and then this one would be A prime. Just that point right there and that point right there. Now I'm only naming them here in the video because then I will be able to talk about them a little bit easier. So A to the line of reflection and A prime to the line of reflection should be the same distance. So if I were to take a tape measure out or a ruler and measured from A to the orange line, and I got maybe 1 centimeter or 1.1 centimeters, I would get the same 1.1 centimeters if I measured A prime to the orange line. Those distances, by definition, need to be the same. So I can go ahead and put down that x plus 1 equals 2x minus 5, because as we said, these two distances here need to be the same. I can either measure them in centimeters to be the same, or I can call them to be the same using my variables and my equation. So I am going to go ahead and solve this equation by moving my x over. And then adding 5 to both sides. So I've gotten all of my variables to one side. I'm getting all of my numbers to the other side. And I get x equals 6. Now these problems, especially questions 13 and 14, are going to be helping you as you are solving problems on pages 12 and 13 in your packet. Have a good afternoon, class.